I am going to do a simple experiment on density. So first I'll run you through the stuff I'm going to use and sort of give you a reason why I designed this activity. But before then, I worked with Lightyear Foundation, and the whole goal of Lightyear Foundation was to run a project in Ghana, which is in West Africa, and in a rural setting where science is taught mainly by copy notes. So in the advanced settings, the students go to the class and they have all sorts of practical approach to science. But in the rural setting in Ashanti region, science was just taught by copy notes. So the students come to the class and the teacher's in front of them just narrating, and the students just keep writing. But we at Lightyear Foundation, which we started a project called Lab 30 in Ghana, wanted to make science practical. Not just practical, but we wanted to make them think deeply and be scientists at such young stages. So we work with basic schools from age 8 to 16, and our whole goal was to make them creative and curious. So if the teacher says density is this and this and that, our focus was to say why. We don't get it, why? But to help us carry out our activities or lessons, what we did was we let them ask questions on what they wanted. We were only complementing their science lessons, and one of the questions that came up was what makes something sink and what makes something float, which essentially is density. So because then it was hands-on and we're trying to make the students scientists, you know. So before I'll take that bottle of water, can I please have a bottle of water?
Oh, do you want?
Yeah. So thank you very much. So this is 2 plastic cups, and we wanted to use local resources, so nothing fancy at all. We have balloons here, we have this, we have coins, and obviously water. So first of all, you're going to do by yourself, because then the whole thing was to make them creative. So after you do it, then we'll discuss on how we could have done it better and what actually you did and how it contributes to the lesson and all of that sort. So everybody can have one. So maybe you'll be here, you'll be here as well. Oh, sorry.
Another one.
Yeah, another one, please. Thank you. Okay, so unfortunately I just have 1 scissors and 1 sellotape, but I'm sure we can manage, you know. So who can tell me what density is? I mean, what is density?
It's weight per unit volume.
Weight per unit volume. So imagine telling a class 4 people density is weight per unit volume. You know, it's like, that's what is in the textbook, but how does it relate to real life, you know? And obviously you have answers like density is when something is heavy, which is true, but then we sometimes forget that there's a relationship between the weight and the volume, which you are saying. So for instance, I could have 2 substances that are heavy of the same material, but if I'm able to change the volume of one of the substance, its density changes. You get it? It's still heavy, but the density has changed. So it doesn't sufficiently carry out the message of what density is. So this is a simple experiment to let the students perceive of how the relationship between weight and volume actually plays out. So you can see this. Yeah, so I'm going to use this. The reason why I chose this also because you get definitions like if something is hollow, then it should float. But will this float? Certainly not. And the next thing we are going to do is, will this float or sink?
Float.
Okay, let's try. We don't know. Okay, so it's floating. It's floating. So your task is that you are going to make this which sinks to float and this which floats to sink. So it will require creativity, hopefully, but I hope I have things on the table to help you achieve that. So I'm not going to run past what I have. So you are going to make use of 2 coins. You don't have to use all. You just have to come up with a creative solution of making what is sinking float and what is floating sink. And I have balloons to help you as well. Then I have scissors, and obviously there's one, but we can share. So I'm going to time you if you don't mind, because we are adults. So okay, so you can take maybe two to a couple. We work in teams. So you can start to work now. So this is this. Yeah. No. Just be creative. So this should float, and this should sink.
At the end of
So yeah, please start work.
I think even if it's just sitting on here, it sits on top of the water. Okay. It's gonna, oops, tape it on. Just tape to this. Yeah, how's that? Make it down. Oh, I think it might work. It's on top of it.
Don't worry, it's fine.
Yeah. I think it's floating now. Is it touching on this side? No, there you go. That's floating. Yeah, is it floating? Yeah.
Well,
Yeah, kind of. Sort of.
okay. I mean,
Yeah? Okay. Okay, there you go.
okay. So sorry if I'm treating you like students, because then I did work with kids. So let's clap for ourselves for a good a good job. So yeah. So yeah. So obviously this was the approach I did, and I gave them time because then they were students, and usually when you are timed for doing something, you sort of have like the agency. What, this is not working, then they try other stuff, and they'll be like, oh, okay, like, so to keep that interest going on, they were timed. And also I gave scores on presentation, creativity, why you sought out to do something, explaining and understanding. But I'm skipping that. We'll just explain the concept. So I will say this group is the winner, because it was form of a competition. There were groups that won based on marks on presentation. I will say this group won. Why? Because then they have sufficiently modified this project such that when you put this on a scale, the weight won't change that much, because then air doesn't weigh that much. But then you've sufficiently increased the volume of the metal ring. So then now the metal ring is less dense than it was before. So this can now float. Even when you push it down into this, it will still float. There was no way it will sink. However, yeah, so sure. And also with this one, if you were to use the smaller coin, it will still float.
Yeah.
Why? Because then you need to increase its weight, but not changing much of its volume. And you realize that the bigger coin doesn't change the volume, but it adds a bit more weight to this to make it sink. Whereas if we were to use a smaller coin, you don't change the weight enough for it to sink. Now, one important factor which I want to draw out of the lesson is to use this. I'm sure some of you are wondering why I did this. This was not part of the experiment, like in terms of modification of the object, but just to give you understanding that if I change the size of the water, the result is still the same. Why? The result doesn't change. Whether it's a big pool, is the sea. Sorry, the sea has salt, so that might influence it. But let's say a big pool with no salt, or a very tiny cup with, the result is still the same. Why? Because the density of the water stays the same. And I wanted to draw out the concept that we are comparing the density of our objects before modification, after modification, to the density of water, which stays the same no matter what happens. So then that's how you can say something is less dense than something or more dense than something. But particularly when you want to explain density, you should always look at the volume in relation to the mass and not just say something is heavier. I mean, you only compare heaviness when you keep the volumes the same. Yeah. So then, one last question, then we are done with my lesson. Why then does a ship float even though it's big? Why would a ship float based on what you've learned from the activity? Why will a ship float even though it's so big?
It's because it's manufactured in such a way that it
Displaces the water.
yeah.
Same amount of water as the weight.
At the end of the day, the ship with all its cargo should be able to float because it's less dense than.
Yeah, but can you explain it using the objects that we've learned?
It's an issue to do with volume
Yeah.
compared to the mass.
Yeah.
Yes.
Yeah. So let me just bring to the experiment. So because we were comparing this volume to the volume of the water, you realize that when you put this into the water and you press it down, the water rises up, which means that this is occupying a space in the water. So what you want to do is that you want to modify this such that its mass hasn't changed that much, but its volume is bigger, so that it will occupy a bigger volume in the water, which its density won't change, but its mass will increase to match up the new volume of the water it's now occupying. Do you get it? So it sufficiently makes this one less dense than the water, even though you've only increased the volume of your object. And that's why a ship floats. So a ship floats because it's designed such that it displaces so much water, which is equals to its weight. So then it will float and not sink. So thank you so much for coming to table 4.
Nice. Thank you.